usually in composite function, the question may ask you to find the range first, because if you see part 2 here, okay, they want to know whether it exists or not. In order for it not to exist or exist, something must be done in the interchange, which I'm going to talk about it later when we reach part 2. Okay, so let's just talk about part 1. Fx is equals to e to the power of 1 minus x. And they did say that the domain is x strictly greater than 0. Okay, so if you are going to use your GC and draw it, remember to restrict your domain. Because of this, let's make our x minimum equals to 0, and x maximum you can put 10 or 20, it doesn't matter. Okay, now from here you will know that the GC will plot out something like this. Okay, or at least you should know that e to the power of negative x has to be going downwards, and it's only for x greater than 0. Now, because it's strictly greater than 0, right? At here, you have to put a circle. Okay, I'm going to use red to put it. You're going to put a red. You're going to put an empty circle here because it cannot include 0. And when x is equals to 0, you put it into here. This is going to be e power 1, or you can just put it as e. So for this, label the graph y equals to e to the power of 1 minus x. For this function, the range of f is from 0, and it cannot include 0, so I cannot use this bracket. I have to use this bracket. If you don't understand the parts about using which kind of bracket, please refer to the videos in front. Okay, comma, as well as the maximum is at e to the power of 1 or e only, and it cannot include e as well, because can you see there's an empty circle here. For part 2, or rather still at part 1, I'm talking about gx, which is equals to ln of x minus 1, where x is strictly greater than 1. So if you plot it out into a GC, the GC will not show you the asymptote. So you have to know that the asymptote of a ln graph depends on this, because you can't ln 0. I know that x cannot be equals to 1, so x equals to 1 is the vertical asymptote. Okay, and if you follow the GC, it will look like this. And what is here? Okay, you have to know that it is 2, or you can just ln x minus 1 equals to 0. Inverse of ln is e, so x minus 1 equals to e power 0, which is 1, x equals to 2, and that is the x-intercept. This is your y, this is your x. Label the graph y equals to ln x minus 1. Now, there are no horizontal asymptotes for ln graph, so the range of g is just going to be from negative infinity to infinity, okay, because it encompasses the whole of the y values. Okay, so the first part I've already asked you to find the range of f and g. Before we do the second part, let's do some recap. Now the question is asking for fg. Okay, so fgx means that we are going to do g first. Remember these 3 circles over here. Okay, if you cannot remember what is the condition to satisfy, x goes first, x is here. If the first mapping is g, then it will become gx. I'm going to clean this up here, so this will become gx. And then after that, I do f over here, this will become fgx. Okay, when you go through, x goes through a mapping of g. Over here, it becomes a y value of g, so this is the range of g. And for f is going to take this here as its x, so this is called the domain of f. Here you see the interchange very clear. For fg to exist, the range of g must be a subset of domain of f. So what is the range of g? Negative infinity to infinity. Is this a subset of the domain of f? Be careful, we're talking about the domain of f. So look at here again, domain is talking about x value is strictly greater than 0 to infinity. Is negative infinity to infinity a smaller set of 0 to infinity? No. Okay, therefore fg does not exist. Okay, yeah, so this is how we prove or disprove whether fg exists or not. Okay, now for part 3, it's going to be a little bit more tricky, so I'm going to put it over here, okay? Now I know that fg does not exist. The question asks you to restrict the domain of g to become from a to infinity. Find the least value of a such that the composite function exists. Define it in similar form and then state the range. Okay, there's going to be four things that is over here. Okay, so first, let me just going to write down the range of g is from negative infinity to infinity. The domain of f is from 0 to infinity. Okay, in order for fg to exist, it must be a subset, right? The range of g must be a subset of domain of f. So now the domain of f is fixed. It means that the range of g must now become at most from 0 to infinity. Okay, the range of g must be from 0 to infinity. Remember, range is talking about x or y value. It's talking about y values. The question is saying that I'm restricting the domain of g to become from a to infinity. So now we are doing backwards. We are using the y values of g to find out what are the possible x values of g. I'm just going to draw this graph over here, which actually we have drawn already. G is y equals to ln x minus 1. Here is x equals to 1. Okay, I only want the range of g to be from 0 to infinity. The x-intercept is 2. Okay, 0 to infinity means I'm only interested in this part of the graph because I'm talking about the range, which is the y values. So the corresponding y values that make the domain for this yellow part, what would be the domain of g? Domain is talking about the x value. So we can see that the x-intercept is 2, right? It does not include 2. And the x values will all go on over here. It will just continue to go on until infinity. So comparing to what the question wants, by restricting the domain of g to a comma infinity, we can say that a must be equals to 2. Okay? Now, then in this case, the composite function can exist because in order for composite function to exist, this part must happen within the interchange. To understand this is very important. If you do not understand this part, then let's go back to the front, rewind it to understand the first part of the question, or even the previous video to understand why the interchange is so important. Okay, if you can understand it and carry on, now the question asks you to define fg in a similar form. Okay, so what is fg of x? Always underline the first one. Keep the f, write down what is gx. What is gx? Gx is ln x minus 1. Then I replace the gx over here. Okay, now I look at f. I replace the x. I'm going to write down fx is equals to e to the power of 1 minus x. I replace the x of this with ln x minus 1. So e to the power of 1 minus ln x minus 1. Okay, and this is going to be your answer. Or if you want to make it nicely, e, when I minus the indices, it means divide. 1 divided by e to the power of ln x minus 1. Okay, when you see e to the power of ln, you have to know this will just negate each other. I'm going to be left with x minus 1, and this would be a better answer. Now, domain of fg, can remember, is equals to the domain of g, domain of the second one. Be careful, don't take the domain of g from the original, because in the first part of the question, I already restrict the domain to become from 2 to infinity, so you can just say x must be strictly greater than 2, and that is how you find fg in a similar form. Okay, so to find the range of fg, we are talking about the y values of fg. All you need to do is to key this into the GC. So I want to key this into my GC. I make it a fraction first. So first on top is e, so I can just put second function ln e to the power of 1 over x minus 1. Okay. Now remember that your domain is from 2 to infinity. So go to your window. your x minimum start at 2, your x maximum go to 10, okay. Your y minimum should actually be the default minus 10, 10. Okay, it will give you a better representation, okay, in the graph. And then you press graph, okay, it looks like this. Okay, it is going downwards. It looks like the original graph. So I'm going to draw this out. Sorry, it's not going to start from here. I only start from when x is 2, because the composite function, the domain of fg depends on the domain of g, and I can only start at 2. So when it is 2, this guy is e to the power of 1 over 2 minus 1. I'm going to sub it into the, sorry, that's the y value. Okay, the x value is 2, the y value is e over 2 minus 1, which in this case is just going to be e itself. Okay, so don't be tricked by the calculator, because you have already restricted the domain to start at 2. You have to draw the graph that looks like this. So this is y as well as this is x. Okay, and this is how you do quite a complicated question on composite function.